Yes, so far we have discussed about the model of direct sequence spread spectrum system. Then we have discussed about how direct sequence spread spectrum works, right? Then its applications. So today we'll discuss about the spreading codes. Okay, so there are a variety of spreading codes which we use in this spread spectrum communication. One is the pseudo noise code. It is also known as pseudo random, or even the maximal length sequence. In short, we call it as M sequence. Okay, and this sequence has very good auto and cross correlation, but it has very small code sets. So that is the drawback of that particular M sequence. And other sequences are, one is gold codes and another one is Kasami sequences. Okay, so we will be discussing about these two codes also. Okay, gold codes and Kasami sequence. And next one is wash codes and Admer sequences. Okay, actually these gold codes and Kasami sequences are derived from the preferred M sequences, right, with similar correlation properties, and it has a large code set. Okay, but to overcome the drawbacks of pseudo noise sequences, the gold sequences have been developed by Gold and Kasami, right? So as I said, the wash codes and Admer sequences are also used in spread spectrum communication, because these codes have zero correlation between the codes when aligned, and they have cross correlation non-zero when time shifted. So, and it has a fixed spreading factor. Okay, so it is possible to have codes of different length which are not orthogonal. So let me see in detail each of these codes. Okay, so as I said, the pseudo noise sequence, right, means pseudo random or pseudo noise sequence actually is a code sequence of ones and zeros. Okay, with certain autocorrelation properties. Okay, so pseudo random or pseudo noise sequence is also known as, I said, the maximum length sequence. Okay, in short, I said it is M sequence. It is a what? Code sequence of ones and zeros with certain autocorrelation properties. The autocorrelation properties of this PN sequence is similar to the autocorrelation property of the white noise. Hence, it has got the name of a pseudo random or pseudo noise sequence. Okay, so let us see how do we generate this M sequence having a length of L. So it is related with this equation. L is equal to 2 power M minus 1. Okay, where M is the number of shift registers. Okay, where M is the number of shift registers. So it is possible to generate an M sequence with a length of what? L is equal to 2 power M minus 1 bits. Means if I use 3 shift registers, means let us say the value of M is 3, then it is what? 2 power 3 minus 1. So 2 power 3 is 8. 8 minus 1 is 7. So I get a sequence length of 7 bits. Okay, so here I have given a general diagram for M stage shift registers. Okay, general diagram for generation of M stage shift register. Means I have M shift registers, right? So I have taken output of some shift registers, and modulo 2 operation is done. Okay, and there will be a feedback with that. Output of that modulo 2 operation will be given to the input of the shift registers. So with that, I will be able to generate the sequence. Let me take one particular example and say how do we generate this pseudo-noise sequence. Okay, so this is the general M stage shift register diagram. Okay. Let's start with this one. Yeah, if I take M is equal to 3, means I will be having 3 shift registers, right? I said L is equal to 2 power 3 minus 1. So 8 minus 1. So the length of the pseudo-noise sequence will be 7 bits. And I said output of some of the shift registers or modulo 2 operation is done. Then output of that modulo 2 means XOR gate is given as an input to the shift register. So that it will be a cyclic shift. Okay. So let me take the example. It is fine. So now come share screen. Yeah. You'll be able to see now this screen. Hello? Hello?
Yes, sir.
So I have taken here an example of what M is equal to 3. Means I have 3 shift registers, means 3 flip-flops connected in series. So I have taken output of each flip-flop as X1, X2 and X3. Here I have taken output of first flip-flop and output of the third flip-flop is given to the XOR gate. So the modulo 2 operation. So output of that modulo 2 adder is connected as an input to the first flip-flop. Okay. So here with 3 flip-flops. Okay. So I am considering the initial state. Okay. Initial state as 100. So it is an arbitrary. Okay. Just I have taken 100 as the initial state. You can take any other state also. So with that 100 as the initial state, right? So for the first clock, means when I apply a clock pulse, it will shift by 1 bit, right? So first 0 will come out. So that is the first this one output sequence, that is 0. Then see X1 is what at the beginning it is 1 and X3 is 0. So 1 XOR with 0 is what 1. That 1 will be fed to the first flip-flop, right? Now it becomes, the next state becomes 110. This is what is shown here. 110, right? Next is 110. So now this one will come out, right? So this is 0 now, output sequence. Now again X1 is 1 and X3 is 0. So XOR of that 10 will be again it is 1. So that will be fed to the first flip-flop. Now the content of the flip-flop becomes 111. So this is the third state, 111, right? So output will be what? The 1, because this will come out, right? So like that for the next clock pulse, now what happens? X1 is 1 and X3 is also 1. So 1 XOR with 1, I will get 0. So that 0 will be fed to the first flip-flop. So the next state becomes 0, 1, 1. So this 1 will come out, right? The output becomes 1. Then next is what? 0, 1, 1, right? So for that 0 is X1 and 1 is X3, right? So 0 XOR with 1, again it will be 1. That will be fed to the first flip-flop. So next state becomes 1, 0, 1. And the output will be this X3, that is 1, right? So now the next state is, see X1 XOR with X3, that is 1 XOR with 1, I will be getting 0. That will be fed to the flip-flop 1, right? Means 0, 1, 0 is the state. So output is 0, right? Now X1 is 0 and X3 is 0, right? So 0 XOR with 0, I will be getting output of this modulo 2 adder as 0. that will be fed to the flip flop 1. So becomes what? 0 0 1. The output sequence will be 1. Then now x1 is 0 and x3 is 1. So 0 XOR with 1, it will be 1. That 1 is fed to the first flip flop. So it becomes 1 0 0. So it comes back to the initial state, right? So this sequence after seventh stage, it will be repeating. Okay, that is why I highlighted with red this one. Okay, I started with the initial state as 1 0 0. So with that, these are the different states, and this is the output sequence I get. So 00 111 01 is my pseudo noise sequence, or I can say this is M sequence, right? I said the relationship between the number of flip flops used and the length of the pseudo noise sequence is this, right? L is equal to 2 power M minus 1 bits, I said, right? In this case, I have used M is 3. So 2 power 3 minus 1 is 7. So this pseudo noise sequence having a length of 7. Okay, that is only I told here. I said the initial state I have taken 1 0 0. Okay, so you can take any other state in out of 7. Okay, it need not be 1 0 0 only. If you start with the 111 as the initial state, the sequence starts from this point. Okay, again it will be repeating after 7 states. I hope you have understood now. This how we get it. It's very simple. Shift register operation, just shifting for every clock pulse, it keeps shifting. And how we say that from which flip flop output should be taken and modular 2 operation is done, that depends on the given polynomial equation. Okay, so here I have assumed that I have taken output of first flip flop and output of the third flip flop, and I have done modular 2 operation. That output is fed back to the first flip flop as an input. Okay, so as I said, any other states, any other 6 states can be taken as the initial state, and will be able to generate the pseudo noise sequence. So with these 3 flip flops, I will be able to get 7 different sequences, right? For each state, 1 sequence I get, isn't it? So if I take 110 as another means initial state, I get another pseudo noise sequence, right? Yes, could you understand this operation? Please note down, do it by yourself. If I am fast, you tell me. So let me repeat once again. As I said, to generate the pseudo noise sequence, okay, I have considered 3 flip flops. Okay, I have considered 3 flip flops, and I said the length of the pseudo noise sequence will be related with the equation is what? L equal to 2 power M minus 1 bits. As I said, M is number of flip flops I use in the circuit, right? So here I have connected 3 shift registers, okay, 3 flip flops. I have taken output of first flip flop and output of third flip flop. Then I am doing modulo 2 operation. Then output of that modulo 2 adder will be connected as input to the first flip flop. Okay, so when I considered the initial state as 1 0 0, 1 0 0 0, right? When I apply a clock, so it will be shifted by this one, right? So whatever the content of flip flop means x3, that will come as output sequence, right? So that will be 0. Now what will become the next state? So 1 is x1 and x3 is 0. So 1 XOR with 0 will be 1. That 1 will be fed to the first flip flop. So now it becomes 1 1 0. That is the second state, 1 1 0, right? Now again, if I apply a clock pulse, this 0 will be shifted as the output sequence, right? The output of flip flop 3 will come out, so that will be the output sequence. Now what will be the input of the first flip flop? Since x1 is 1 and x3 is 0, so 1 XOR with 0 will be 1. So output of the modulo 2 adder will be 1. That 1 will be fed to the flip flop 1. So now it becomes what? 1 1 1, right? This 1 1 0 will be shifted by 1 bit. So it becomes 1 1 1, and output sequence will be this 1, right? So like that it continues till what? Till the initial state repeats. See, after 7 states, okay, after 7 states, again the first state is repeating. So that sequence will repeat. Okay. So now I think you can take this as an example and do it by yourself. I have taken here 4 flip-flop, that is 4 flip-flops, that is m is equal to 4. So now, what is the value of L? L will be equal to, I said 2 power m minus 1, right? So since m is 4, so 2 power 4 minus 1. So 2 power 4 is 16. 16 minus 1 is 15. So the pseudo-noise sequence length will be 15. It is 15 bits. And you can take this as initial state, 1000. 1000 is the initial state, and do it by yourself and tell me what is the output sequence. So till that I will pause. Yes, any other participant, please tell the answer. One person could do it. How much time it takes? Yeah, I think from my side only I am giving the answer. So this is what the sequence. Okay. So initial state was 1000. Initial 1000. So for first clock pulse, this 0 will come out. So that will be the output sequence, right? For the next clock pulse, what happens? I said x3 and x4 are XOR. So 0 XOR with 0, it will be 0. That 0 to the first flip flop, right? So it becomes what? It is shifted by 1 bit, right? This side. So it becomes 0 1 0 0.
Yes, sir.
So 0 1 0 0. So this 0 will come here, right? Then now x3 x4 again it is 0 0 only. So 0 0 0 again it is 0. That 0 will be fed to the first flop. So this 0 1 0 0 will be shifted by 1 bit. So it becomes 0 0 1 0. So this 0 will come as output sequence, right? Again now what x3 is 0, x3 is 1 and x4 is 0. So 1 XOR with 0, it is 1. So that 1 will be fed to the first flip flop. So this one. So now it becomes 1 0 0 1.
1001.
Yeah, 1001. So this one for the next clock pulse. So this 0 1 0 XOR with 1 will be 1. That one will come to x1, right? So it becomes 1 1 0 0 next state. So this will be there. Again next 0 0 is 0 XOR with 0, it is 0. That 0 will come to here. So shifted by 1 bit means 0 1 1 0, right? So next is again 1 0 means it is 1. So 1 0 1 1 it is. So this one will come out. Then 1 XOR with 1, it is 0. So 0 will come here. So 0 1 0 1. Right now again 0 XOR with 1, it is 1. That will come here. So 1 0 1 0 it is, right? So like the 1 0 1 XOR with 0, it is 1. That one will come here. So it becomes 1 1 0 1, right? So then 0 XOR with 1 will be 1. So that one will come here. Means 1 1 0 1 1 1 0 it is, right? So now again, so 1 XOR with 0, it will be 1. So that 1 will come here. Means it all 4 ones it is, right? So now 1 XOR with 1, it will be 0. So that 0 will come to the first flip flop. Means it becomes 0 1 1 1, right? Then again 1 XOR with 1, it will be 0. That 0 will come to first flip flop. Means 0 0 1 1. So 1 XOR with 1, it will be 0. That 0 will come to first flip flop. So it becomes 0 0 1. So 0 XOR with 1, it will be 0. So that 0 will come here. Means it becomes what? 0 XOR with 1, it will be 1. That 1 will come to first flip flop, right? So 1 0 0 means it is the first initial state. So whatever the content of x4, that will be your output sequence, right? So with this I can say, so 0 0 1 0 0 1 1 0 1 0 4 ones is the code of the pseudo-noise sequence or M sequence, I can say. Okay. So with this, is it clear about the generation of M sequence or pseudo-noise sequence? Like
Yes, sir.
Yes, is it clear or do you have any doubts, sir?
No doubt, sir.
No doubts,
Yes,
no? It is
sir.
clear. Okay. Then let me go to the next one. Why it is stuck? Right. So let me try to say what are the properties of this pseudonymous sequence. Let me stop sharing. Do this. And share. Last 4 minutes is left out. Yeah. So nothing. Okay, fine. Yeah. So the major task of the pseudonymous sequence is what? To spread the bandwidth of the modulated signal to the larger bandwidth, right? And this pseudonymous sequence should be able to distinguish between different users, right? Utilizing the same transmission bandwidth. This already we have discussed in CDMA, right? How it is possible to use the same bandwidth by multiple users, right? So these are the major tasks of the pseudonymous sequence. So just I have written here, this sequence, M sequence or pseudonymous sequence is periodic with period L. Okay, and each period contains 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. Okay, just to consider the example. So as I have taken example, m is 3 and the length of the pseudonymous sequence was 7, right? With the initial state 100. So this was my output sequence, right? So in this, what we are observing is the number of zeros, right? The number of zeros will be what? 2 power m minus 1 minus 1 means 2 power m minus 1 means what here? The value of m is 3, right? So 3 minus 1 is 2. So 2 power 2 is 4. 4 minus 1 is 3. So 3 zeros are there. Okay? 3 zeros are there. And how many ones are there? I have that is 3 minus 1 is 2, right? Means 2 power 2 is 4. So 4 ones are there. That is what this one. 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. Okay? So I hope with this it is clear, this concept. Right? So this pseudonymous sequence is periodic with period L and it will have what? 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. Okay? So is it clear?
Yes, sir.
Okay. So last 1 minute is left out. If you have any doubts, you can ask me. And I think I will continue tomorrow. Okay, I have tomorrow second hour, no? So no doubts.
No, sir.
So is it clear with whatever I have taught today? I just said what is a pseudo noise or M sequence. So the same name, 3, right? Why it is called pseudo noise or pseudo random sequence is because that sequence is having the property, that is autocorrelation property of a white noise. Hence it is called a pseudo noise or pseudo random noise. Okay, and it is also called as a maximal length sequence because we use M stage shift resistors to generate that sequence. And I said this sequence is periodic with period L, and this sequence will have 2 power m minus 1 ones and 2 power m minus 1 minus 1 zeros. So with the example what I have considered here for 001101 the sequence, so clearly it indicates that it has 3 zeros and 4 ones.